Hi everyone. In this lesson we're going to take a look at atoms, what makes atoms of different elements different from each other, what pieces make up atoms, and also what atoms really are. Now we've been talking about elements, compounds, atoms, pure substances, mixtures, matter since the very beginning of the year, but now we're really going to focus in on what makes an atom an atom. Now we know this definition. Atom is the smallest part of an element. But how many elements are there? What makes one atom different from another? What makes one element different from another? Well, let's take a look at all those elements. Okay, the elements are all listed on the periodic table of the elements, and you can see there's right here, this one goes to 118, although these ones that are named with U's in them, they're not discovered or made yet, so we can't really count those, but we're going to go with it. Close enough to 118 elements that we're going to go with 118 elements. What makes every single one of these elements unique? Well, every single one of these elements has their very own atom. If I take, for instance, titanium, very strong metal, its atom is different than an atom of aluminum, which is a very lightweight, also fairly sturdy metal, but not nearly as strong as titanium or, say, iron. So what makes titanium different than aluminum? And then we have helium, which is completely different than either of those things, because helium is a gas. It's lighter, less dense than air. It'll float away. These are both metals. Then I have stuff down here that's radioactive. What makes these elements the same, and what makes these elements different? Well, the smallest part of an element is an atom, but atoms are not the smallest part of matter. Okay, atoms are actually built out of other things themselves, and by putting those building blocks together in different ways and different combinations, we get different elements. Okay, so remember, each of the elements has its own unique atom. Okay? So all atoms of different elements are different, but they're all built out of the same pieces. All atoms are built of the same pieces. Now, modern atomic theory can be traced back to a guy named John Dalton, and he had a few ideas about atoms. He said atoms of the same element are identical, which we are going to learn is not quite exactly right, but they're pretty close to each other. He said atoms of different elements are different, which is true. And he also said that when atoms combine to make compounds, the atoms lock together, and they always lock together in the fixed ratio, which is also true. He also thought atoms are the smallest things, and this one has changed quite a bit. Okay, so all atoms are actually built of smaller particles, and these smaller particles are what we call subatomic particles. Subatomic meaning lower than atoms. Okay, so subatomic particles. Now there are three subatomic particles. You guys are probably familiar with them. If I say protons, neutrons, and electrons, you guys are like, yeah, we know what that is. We know about protons, neutrons, and electrons. We learned about them our whole life. Okay, so good, but okay, we got to get a little bit more than that. We need to know more than just that elements are, or atoms are made of protons, neutrons, and electrons. We want to know what these things are. Okay, so it helps to have a basic understanding of the atom. At the center of every atom is a dense, heavy region called a nucleus. And the nucleus is actually very small compared to the rest of the atom. Okay? If you were to imagine an atom being the size of a football field, the electrons are way out on the outside. They would be like the lights out on a stadium. Okay? The nucleus would be right in the center of the field, and it would be the size of a marble. Okay? So atoms are very small. Most of their space is occupied by electrons flying around the outside, but most of the mass of the atom is in this dense, tiny center called the nucleus. And the nucleus actually contains protons and neutrons. Okay? So nucleus, this is a word we should know. Nucleus is the dense center of an atom. And it contains two particles. It contains protons. Okay. Now protons are probably the most important particle for an element because they determine what it is. So protons, this is a particle with a positive charge. Okay. That's not what makes it so special. Okay, maybe it is. Okay, but the reason the protons are so special, every single element has its own unique atom, and by that we mean every single element has its own number of protons. Okay, the number of protons, the number of protons determines the element. Okay. On several quizzes and tests, you guys have had the question, if you cut an element or an atom in half, is it still the same element? And the answer to that question is definitely no. Okay, the number of protons determines the element. So let's go back to that periodic table. Okay. If we take a look at the periodic table, we see that these elements all have their own numbers. Okay, that number is called atomic number, and it actually tells us how many protons an element or an atom of that element has. So if we take a look at hydrogen, the lightest, smallest element here, it has 1 proton in it. If we go all the way over to titanium, it has 22 protons in it. If we come down to uranium, it has 92 protons in it. So the number of protons is different for every single atom. So if I were to take a gold atom, say, and cut it into smaller pieces, I'd end up with atoms that have smaller numbers of protons. And so I might make some other element, but it's not going to be gold anymore because it doesn't have 79 protons anymore. We broke the atom, and when we break the atom, we change what it is. All right, so protons, they're in the middle. They're the particle with a positive charge. The number of protons determines the element. If it doesn't have, okay, every atom of carbon has 6 protons. If it doesn't have 6 protons, it is not carbon. And we call the number of protons the atomic number. Okay, that's the number I was just showing you on the periodic table. The atomic number is the number of protons. You need to be able to look at a periodic table and determine the number of protons of an element. Now, the other particle that's in the nucleus is this thing called the neutron. Now, this one was a little bit tricky to find and explain because neutrons have exactly no charge. Okay? A proton has a positive charge, which means it'll interact with other charged particles, so it makes it easier to find. A neutron has no charge. It won't interact with positive things. It won't interact with negative things. It just hangs out. Okay? It is in the nucleus. It does a couple different things. This is the part that John Dalton really didn't know about in his model of the atom. It has 2 roles to play. Okay? It gives mass to the atom. Okay? In fact, protons and neutrons have a very, very, very similar gives to the atom. It gives mass to the atom. Protons and neutrons have a very similar mass. Protons and neutrons almost identical mass even. The neutron has slightly more mass, but not enough that we're going to worry about it. It gives mass to the atom. The other thing it does is it gives stability to the atom. Okay. Now, we've talked about radioactive decay. That's when heavy, unstable elements go through fission and break apart into smaller, more stable elements. And since they're losing energy from going from unstable to stable, that energy is released generally as thermal energy that warms the core of the Earth. That's how nuclear power plants produce electricity. They convert that thermal energy into electricity. The neutrons are very, very crucial in the process of radioactive decay. Okay? So they have no charge at all, but they're in the nucleus, and it gives mass and stability to the atom. If the wrong number of neutrons are there, then the nucleus is not going to be stable, and it can go through radioactive decay. Now, the last particle is the particle that we mentioned at the beginning that's floating around on the outside. Okay? So this is outside the nucleus, orbiting the nucleus, if you will. Orbiting the nucleus are electrons. Electrons are what we're going to be very, 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 very concerned with for basically the rest of this unit on chemistry, because electrons do lots and lots and lots and lots of things. They have a negative charge, okay, and that means they're going to balance the charge of the protons. So the atom itself is going to be neutral, not because it's not got charged particles in it, but because the positive and negative charge cancels. Okay? So this is a negative charge. Like I said, it's outside the nucleus, and it determines properties of the element. Okay? So if we think about one of those elements like oxygen, the reason oxygen is such a reactive element, we need it for fire, we need it for life, we need it for lots of things. It's a very reactive element, and the reason for that is because of the electrons on the outside of that atom. They're involved in lots of different processes and provide lots of chemical potential energy, which is used in lots of reactions. Okay, helium, the reason it's so very stable and doesn't react with anything is because of the way its electrons are arranged. Its electrons on the outside don't need to make any bonds. They're very, very stable, and they aren't going to change. Okay, so we're going to spend some time talking about the electrons and what they do. Now, the last thing to know about electrons, these are incredibly small. Okay, incredibly small. The nucleus, like I said, is tiny. It doesn't take up very much space, but the nucleus has almost all the mass of an atom. Okay? One electron, by the way, E minus is the symbol for electron. One electron has 1/1846 the mass of a proton. Okay? Now, because protons and electrons have to have the same number in an atom because atoms are neutral, okay? Atoms are neutral, which means number of electrons equals the number of protons. Okay. Then we can actually look at the periodic table and figure out how many electrons something has. Okay, so I'm going to come to the heaviest element on here, ununoctium, element number 118. That 118, that atomic number, that tells me this has 118 protons. I'll write protons as P+. Because it's a neutral atom, it also has 118 electrons, E minus. So the very heaviest element that we know of at all on the periodic table has 118 electrons. It takes almost 10, well, more than 10 times that amount to even get close to the mass of a proton. We don't really include the electron in the mass of an atom because they're so small, their mass is so insignificant that it doesn't affect the mass of the atom appreciably. But they are incredibly involved in bonding, and they do determine lots of things about the atom besides its mass. So the chemical properties are going to arise from electrons. The nuclear properties, the mass of the element, those are going to arise because of the protons and neutrons. And because the protons are actually responsible for attracting the electrons, that's why elements with different protons have different properties. That's why elements with, or atoms with different numbers of protons are actually different elements. Those number of protons are responsible for bringing in electrons, and then electrons have the different properties. So protons determine the element. Every atom of a different element has a different number of protons. They're in the nucleus. They have a positive charge. Neutrons are also in the nucleus. They have no charge. The electron orbits the nucleus pretty far from it, actually, has a -1 charge, and balances the charge of the atom. So we have protons, which is a 1+, neutrons, which is 0, no charge, electrons, which are 1-. And it is correct to write the sign of the charge after the 1, not before, but after.